We saw in the last clip that the relationship of the slopes between parallel lines is very simple. They're the same because they run in the same direction. Somewhat more complicated is the relationship in slopes between perpendicular lines. So to make clear, perpendicular lines cross at right angles. And so we usually use a little box here in math to indicate a right angle or a 90-degree angle. Perpendicular lines. And one thing you might initially notice is well, how do the slopes relate? If this line has a positive slope because it's rising, its perpendicular line must be falling. It has a negative slope. So that's one observation we can make about perpendicular slopes. Their signs are opposite. One's positive, one's negative. Is that all there is to it? Well, let's explore that for a moment. And I'm going to draw a line with, I'll make it deliberately have a slope of 1/3. And pass through the origin. So here's my example line. And the slope, again, is 1/3 because there's a rise of 1 unit and a run of 3 units. So we'd say slope is 1/3. Now let me draw another line which crosses through the origin and has a slope of negative 1/3. So if I did that, then I would go down 1 and over 3 to the right, and the line would decrease. So this line has a slope of minus 1/3. They're opposite sign, but I think you'll agree that they are definitely not perpendicular. They do not cross at 90-degree angles. All right, so it's not quite that simple, is it? Some textbooks end up proving the relationship between perpendicular lines of other slopes. And these proofs are, I find, somewhat complicated. I had a student several years ago make an observation when I was proving this perpendicular slope connection. And his observation was so wonderfully simple, I decided to adapt it. And so this is probably the simplest argument you'll find for how perpendicular lines relate to each other. So here's what I'm going to do. I'll say, well, okay, you give me a line. Suppose you give me this line. And I'm going to say, among friends, it doesn't matter where it is, right? We're going to make it go through the origin. And so this line has a slope of m. And let's suppose it went off this direction. Okay, now if I go over 1 unit, then I have a triangle. I'm creating a right triangle because the base of my triangle is on the x-axis and the vertical side runs parallel to the y-axis. So these sides are perpendicular. It's a right triangle. And since this is a run of 1, and that's height divided by, or rather rise divided by run is going to be m, my slope, then what's the length? That's length 1, this is length m. And so the slope for this line is m over 1, which is simply m. All right, so there's our generic line with slope m. Now, what we're going to do is, I think, kind of clever. And this got this from my student's suggestion. If we take this triangle and rotate it 90 degrees, and I'm just going to decide to rotate it this way. So I'm going to keep the same triangle, but spin it down below here. And I'll try to draw it as the same as I can, but okay, that's close enough. I've created a new line which runs this direction And since I rotated by 90 degrees, then you would expect that those lines are perpendicular, wouldn't you? One line rotated by 90 degrees creates the perpendicular line. And I have the same triangle down here. I didn't get it quite exact, but try to imagine this triangle is identical to that one. Now what is the slope of this line? Well, to drop from this point down to here, my rise is actually a fall. And I've gone a distance of 1, but since I've gone down, I would say that's -1. And the run in this direction is the same as this distance, which is m. So my red line here has a slope equal to rise over run, -1 over m. Well, that should do it, because if I know this slope, m, then this slope is what? It's the opposite sign, and it's the reciprocal of m. So we take this number, invert it, and change the sign, and that gives us the perpendicular slope. So I'm going to write that up as a rule. Slopes of perpendicular, that's the math symbol for perpendicular, an upside down T. Slopes of perpendicular lines are opposite signed reciprocals. Okay, so that sort of recaps what we just did. Let me give you a quick example before we go on to work our problem at the top of the board. Suppose I have a line with a slope of 3/7 or -3/7. So I label this M1 for slope of line 1. This line has a slope of -3/7. The a perpendicular line to it would have a slope of +7/3. So you would change the sign from negative to positive in this case and invert the fraction, 7/3. So these lines are, these would describe lines which run perpendicular to one another. One other little observation about this business here. If you multiply perpendicular slopes together, you always get -1. And so for example, if I multiplied those together, -3/7 times 7/3, then you would find the 7's cancel, the 3's cancel. So I have nothing but 1's and a negative left over. So that works out to be -1. Some textbooks describe this rule of perpendicular slopes in that way. The product of these slopes is always -1.